Welcome again. Today we are going to start new lesson in the Science 1. Name of that lesson is heat. The major outline points of these lessons are latent heat, then regelation, anomalous behavior of water, dew point temperature, absolute humidity, relative humidity, then specific unit of heat, specific heat capacity, principle of exchange heat. These points we are learn in this topic. Okay. Then first of all, before going to start the lesson, some points we clear that. What is the difference between heat and temperature? What is difference between heat and temperature? Heat is a form of energy. Particles of matters possesses potential energy and kinetic energy. Okay, the total energy, that means potential energy plus kinetic energy of all particles of matter in a given sample is called a thermal energy. Okay, then when two bodies at different temperatures are in thermal contact with each other, there is a transfer of a thermal energy from a body at higher temperature of the body to the lower temperature of the body. This energy is transferred is called heat, and it is expressed in a joule. Temperature is a quantitative measure of a degree of hotness or coldness of the body. It is expressed in a centigrade, Fahrenheit or Kelvin. Temperature determines the direction of energy transfers. Okay. Now I clear this point. What is the difference between heat and temperature? Heat is a form of energy. Okay. Particles particles of matter, that means atom, molecule, nucleus, etc. Particles of matter possesses, all particle of matters possesses potential energy and kinetic energy. Okay, the total energy, that means total energy means potential energy plus kinetic energy, that is called a total energy. Total energy of all particles of matter, total energy of all particles of matter in a given sample is called a thermal energy of a particular given sample is called a thermal energy. When two bodies at a different temperature are in thermal contact, two bodies at different temperature, one's temperature is max and one's temperature is minimum, and both bodies come in contact with thermal energy, okay, with each other, then there is a transfer of a thermal energy. There is a transfer of a thermal energy, that means higher temperature to the lower temperature. Okay, from a body of higher temperature to the body of lower temperature. This energy transfer is called heat. Are you get my point? Are you understand? Suppose this is one body, we will take an example like this. Suppose this is one body and this is another body. This temperature is different and this temperature is different. Okay, but particles of matters, all particles of matter, that means which are including potential energy and kinetic energy. Every particles have potential energy and kinetic energy. Okay, both potential, that means total energy of all particles, that's called as a thermal energy. Okay, we are taking the two particles having a different temperature, then come in contact with thermal energy. Then what happens? Higher temperature of the body, heat is transferred higher temperature of the body to the lower temperature of the body. That transferring of heat, that transferring of the temperature from higher to lower, that is called a heat. Okay, and temperature is a measurement, quantitative measurement. What is the temperature? Temperature is a quantitative measurement which is tell us that is a body is hot or body is cold, and expressed in a degree centigrade, Fahrenheit or Kelvin. That is a quantitative measurement, that is a temperature, and heat, that is a transferring of temperature, that is called a heat. Okay, then what are different ways heat transfer? ways of heat transfer, that is conduction, convection and radiation. By three ways heat is transferred: by conduction, by convection and by radiation heat is transferred. Now come to the first point. What is a latent heat? Okay, when there is a change of state of substance. What is the, there are major three states of substance: solid, liquid and gases. Three major states of substance. Then what happens when there is a change of state of substance: solid to liquid, liquid to gas, solid to gas? Heat energy is absorbed by the substance, or heat energy is removed from the substance at a constant temperature. This heat energy is called latent heat of a transition. What happens, when there is a change of a state of substance, suppose a solid state converted into liquid state, or liquid state which is converted into gaseous state, or solid state converted into directly gaseous state. That means changes of state of substance. At that time heat is absorbed by the substance or heat is removed by the substance. What happens when states are changes? At that time heat is absorbed or heat is transferred or removed from the substance at a constant temperature. This heat energy is called latent heat of the substance. That is called a latent heat of a transition. Latent heat per unit mass of the substance is called specific latent heat. Latent heat per unit mass of the substance is called specific latent heat. The amount of heat energy absorbed at a constant temperature by unit mass of the solid to convert into liquid phase, it is called a specific heat of fusion. I repeat it, please listen concentrately. Amount of heat energy absorbed at constant temperature. Amount of heat energy is absorbed at a constant temperature by mass unit of solid to convert into liquid phase. Solid converting into liquid phase, then what amount of heat energy is absorbed to converting liquid phase, that is called a specific latent heat of a fusion, and the constant temperature is called a melting point of the substance. What constant temperature it is melt, that is called a melting point of the substance. Amount of heat energy absorbed at a constant temperature by unit mass of a liquid to convert into gaseous phase, called as a specific latent heat of vaporization. First of all, absorbed called as a latent heat of latent heat of fusion. And when amount of heat energy is absorbed at a constant temperature by mass unit of liquid to convert into gaseous form or gaseous phase, it is called specific latent heat of a vaporization, and the constant temperature is called as a boiling point of that substance. Specific latent heat is expressed in joule per kg, erg per gram, kilogram per kilojoules per kg, kilokelvin per kg, like this. Okay, here at a pressure of 1 atmosphere, what is melting point of water or ice? Melting point of water is 0, boiling point of water is 100. Okay, then a specific heat of fusion, that means ice, water to ice, that is 333, or ice to water 80 degree. That means this is a chart which is presented in your textbook. You may look this. Okay, from this you can get the information from copper, gold, silver, lead, etc. Okay, then regelation. Second point is that regelation, the phenomena in which converts ice convert into liquid. The phenomena in which ice converted into liquid due to applied pressure and then reconvert into ice once the pressure is removed is called regelation. Means, are you understand this my point? Are you understand my point? The phenomena in which ice convert liquid convert, that means convert or liquid into applied pressure. Ice, suppose we are taking a ice and ice converted into liquid by a pressure, applied pressure, and reconvert into again ice, means ice converted into water and reconvert into the ice when we remove the pressure, that is called regelation. Okay, then next point is that anomalous behavior of a water. What is anomalous behavior of water? If water is heated from 0 degree to 4 degree centigrade, when water is heated from 0 degree to 4 degree centigrade, it contracts instead of expanding. That means it contracts. At 4 degree, the volume is minimum. At 4 degree, volume is minimum. If water is heated further, it expands, that is its volume increases. That means 0 degree to 4 degree, it contracts instead of expanding. At 4 degree, its volume is minimum. If further water is heated, it expands, that is volume increases. This abnormal behavior of the water, in the temperature range, that is 0 degree to 4 degree, is called anomalous behavior of water. The density of a water is maximum is 4 degrees centigrade. Hope's apparatus is used to study anomalous behavior of water. Hope's apparatus is used to study the anomalous behavior of a water. Okay. Then the next point of this lesson is dew point temperature. If the temperature of unsaturated air is decreased, a temperature is reached at which the air becomes saturated with the water vapor. This temperature is called dew point temperature. I again repeat it. If temperature of unsaturated air, not saturated, temperature of unsaturated air, a temperature is reached at which air becomes saturated. Temperature at which air becomes saturated with water vapors. This temperature is called dew point temperature. That means when we find on the leaves of plants at early in the morning in a winter season. Okay, this is a dew point temperature. Now, absolute humidity and relative humidity. The mass of water vapor present in its unit volume of air is called absolute humidity. Generally, it is expressed in kilogram per meter square. That means mass of water vapor present in unit volume, means what is mass of water vapor present in unit volume of air. Suppose we are taking 1 unit volume of air. In the air, what is mass of water vapor? That is called absolute humidity and it is expressed in kilogram per meter square. And relative humidity, the ratio of actual mass of water vapor contained in air to the given volume and temperature to that required to make same volume of the air saturated with water vapor at the same temperature is called relative humidity. The ratio multiplied by 100 gives percentage of relative humidity at the dew point, and humidity is 100%. Again, this explain what is you just know what is the absolute relativity humidity. Absolute humidity means particular 1 unit of air, what is the mass of water vapor present in 1 unit of air, that is called absolute humidity. And relative, the ratio of actual mass of water vapor, the ratio of actual mass of water vapor contained in air for a given volume and temperature to that required to make same volume of air, saturated air water vapor at the same temperature is called relative humidity. This ratio multiplied by 100 gives the percentage relative humidity. At dew point, relative humidity is 100%. Okay. Then what is unit of a heat? Heat is expressed in a various unit. Heat is expressed in various units, that is a joule, erg, calories, kilocalories, etc. The amount of heat necessary to raise temperature of 1 gram of water by 1 degree centigrade from 14.5 centigrade to 15.5 centigrade is called 1 calories. That means 1 degree centigrade to 14.5 centigrade. 14.5 degree centigrade to 15.5 degree centigrade is called 1 calorie. The amount of heat necessary to raise the temperature of 1 kilo of water by 1 degree to 14.5 degree to 15.5 degree is called a 1 kilocalorie. Okay, that means 1 kilocalorie is equal to 4.18 into 10 raised to minus 1 joule. Now, next point is that a specific heat capacity denoted by C. The amount of energy required to raise the temperature of unit mass of an object by 1 degree centigrade is called a specific heat capacity, or simply specific heat of object, and it is expressed in a joule per kg, earth per gram, calories per gram, kilocalories per kg. That means amount of heat energy, what amount of heat energy is required to raise the temperature of the object. Okay, suppose we want to raise the suppose this is one object, we want to raise the temperature of this object, then what amount of energy is required to raise the temperature by 1 degree centigrade is called a specific heat of that object, or that is called a specific heat capacity of that object, and denoted by joule per calories, or earth per grams, or kilocalories per kg. Okay, then heat is absorbed by an object where mass of the object and m is the mass of object and delta t is the increase in the temperature of the object. Heat lost, that is heat is given by the object, that is equal to mc delta t, and delta t is decrease in the temperature of the object. Okay, then next point is that principle of heat exchange. Principle of heat exchange. If a system of a two object is isolated from the environment by keeping it inside the heat resistant box, then no energy can leave the box or enter in the box. In this situation, heat energy lost by hot object is equal to heat energy gained by the cold object. In due course, two objects attain same temperature. That is a heat exchange. I explain this point again. Okay. If a system of two objects is isolated from the environment by keeping it inside a heat resistance box, there is no energy can leave the box or energy enter in the box. In this situation, heat energy lost by hot object is equal to heat energy gained by the cold object. That means both objects have a same temperature. That is called a principle of a heat exchange. Okay, then additional but important information: sublimation, that is part the phenomena in which solid directly passes to gaseous state without passing through the intermediate liquid state is known as a sublimation. That means conversion of a solid substance into the direct gaseous without passing through liquid. That means solid cannot convert into liquid and liquid to gaseous. No, solid to gaseous that the phenomena in which solid substance converted into gaseous form, that process, that phenomena is called a sublimation process. Okay, iodine, ammonia, have the property, or they possess the property of a sublimation. Effect of pressure on a melting point of a substance. At a given pressure, solid melt at a fixed temperature. A charge in the pressure changes melting point of the substance in the case of solid, which expand on melting. Okay, in this case, solid which expand on melting increase the pressure rises melting point of the solid, that is lead and wax. In this case, solid which contracts melting and increase the pressure loses of the melting point. Ice, anatomy, antimony and bismuth. Okay, then the boiling point of the liquid depends on, listen this point, boiling point of the liquid depends on pressure on the surface, and increase in the pressure rises boiling point of the liquid, while decrease in the pressure lowers boiling point. Is it clear the point? Again I repeat it. The boiling point of the liquid depends on, that is the effect of pressure on the boiling point of a point of liquid. Boiling point of a liquid depends on pressure on its surface. What is the pressure on that surface? The boiling point depends on it. And increase in the pressure, suppose we increase the pressure, rises boiling point. Pressure is increased, the boiling point is rise of the liquid, while decrease the pressure, lower its boiling point. Pressure is decreased, lower the boiling point. Pressure increase the boiling point. Okay, so pressure, effect of the pressure, boiling point of the liquid depends on surface of the pressure. Okay, here these points are clear from latent heat to the principle of a heat exchange. Latent heat means what? Then what is the regulation, anomalous behavior of a water, dew point temperature, absolute humidity and relative humidity. Both are different. Absolute means actually, and relative means with related this. Then unit of heat, specific heat capacity, what amount of heat energy is required to conversion from one state to another state, that is the specific heat capacity, the principle of exchange. These points are today we learn in this topic. Okay, here lesson is finished. If you have any problem, you may directly contact me. Okay, thank you.